Continuation of our lecture in kinematics in one dimension. This is one-dimensional motion in vertical line, or motion under gravity. So we first need to determine its sign convention. So any vector quantity directed upward will be taken as positive, and directed downward will be taken as negative, as shown in the figure below. So since this is a vertical motion, so we take positive direction, which is going up, and negative direction will be going down. So according to this sign convention, displacement S will be taken as positive if final position lies above initial position, and negative if the final position lies below initial position. Let's say if you are on the top of a building, then for example you drop a ball. So let's say this is its initial position. So when the ball drops, let's say it hits the ground, so this will be its displacement S. And based on the sign convention, the final position of the ball is right below, so that is S is negative. So if the ball is thrown up vertically upward, let's say you are on the ground, say this is the ground level. Like for example, a person throws the ball upward, vertically upward. So this is its maximum height, let's say final position. So the initial position is right on the ground, and final position is above the initial position. So that is, the displacement is taken as positive. Okay, now lies above the initial position, and negative, and the final position lies below the initial position. Okay, then velocity, it's either initial or final, will be taken as positive if it's upward, and negative if it's downward. So let's say for example I throw the ball upward, so velocity here is positive. Like for example here, if I drop the ball going down, so the direction of the ball is going down, so it is negative. So acceleration A is always taken to be negative acceleration due to gravity, and acceleration due to gravity is equivalent to 9.81 meter per second squared. So now free fall. So free fall, when the motion takes place under the effect of gravitational attractive force only, the motion is known as free fall. Like for example, the previous example, if you drop a ball from the top of a building, or let's say you throw a ball vertically upward, then the ball returns or comes back to the ground. Okay, so here free fall does not mean that the particle is falling down only. Even if the particle is rising up or is momentarily at rest at highest position, but if only gravitational forces is acting on it, then motion will be called as free fall. Okay, so in this in the equations of motion, we replace acceleration by negative g, or that is the acceleration due to gravity, minus sign, because acceleration is always directed downward based on the sign convention. So our formula on our previous lecture is final velocity is equivalent to initial velocity minus I plus acceleration multiplied by time. So acceleration will be replaced by negative g. So we will get final velocity will be equal to initial velocity minus the product of acceleration due to gravity and time. Okay. Similarly, original formula on our previous lecture is uh, distance initial multiplied by time plus 1/2 a t squared. This is in horizontal motion. Okay, so we replaced a or acceleration by negative g. We get this one. And last is the square of the final velocity is equivalent to the square of the initial velocity plus twice the product of acceleration and displacement. And we replace a as negative g, we get this one. So these are the basic formulas under pre-fall. So additional formula. So let's say from the given figure, a body is dropped from a height h. Let's say that is the top of the building. Let's say a ball is dropped from this point going downward. So its motion is acted upon the gravitational pull. So what will be the time taken by the body to reach the ground? So that will be the first question. What will be the time taken by the body to reach the ground? And the velocity just before reaching the ground. So just before reaching the ground, that means before the object or particle comes to rest. So that becomes our final velocity. Is known. That is the second question. And the first question is what will be the time? So total time taken. So from this point, initial position up to its final position. So time taken, say t. So the answer for the first question will be this one. What will be the time taken? So the answer must be time taken before reaching the ground will be equal to the square root of twice the height all over acceleration due to gravity. So acceleration due to gravity is 9.81 meter per second squared. So this is a constant value. Okay, 9.81. So how do we get this one? Let's say t will be the time taken just before reaching the ground, right? Or the time taken for the body to reach the ground. So initial velocity, so simply that is drop. So when we say drop, initial velocity will be equal to 0. That is at rest. There is no force applied. You simply drop something. Okay. Then the displacement s just before reaching the ground will be height, and that is below the initial position. So I would suggest this is negative h. Recall design convention. Okay, and then time taken represents t. Okay, now using formula of displacement, so that is s will be equal to initial velocity time minus 1/2 gravitational acceleration t squared. So we substitute the values. S is negative h will be equal to initial velocity is 0, then multiply by time taken, okay, then minus 1/2 acceleration due to gravity time squared. Okay, t is taken as time taken. Okay, then any real number that is multiplied by 0 is 0. So therefore this is negative h will be equal to 0 minus, so I will not write 0 anymore, so that will be negative 1/2 gt squared. Okay, now solving for time, so dividing both sides by negative 1, so the negative sign will be eliminated, and simplifying the equation, this will give you t squared will be equal to 2h all over g. And taking the square root of both sides, okay, solving for t, then square root will be eliminated, and you simply have this formula. So that is some of the problem. This is the question itself. So what will be the time taken by the body to reach the ground? Then in this case, this is the scenario. Like for example, a ball is dropped from the top of the building. So majority of the question, this one. So you can use right away this formula. Okay. Now, second question will be the velocity reaching the ground. Okay. So the velocity reaching the ground. So velocity. So the answer is this one. But then in reality, that is the final velocity will be equal to square root of 2g then h. Negative sign indicates downward direction. Specific problem. Okay, so how do we solve this? Now I will use our formula of final velocity is equivalent to initial velocity minus acceleration due to gravity and time. Now final velocity will be equal to initial velocity based from the given previous initial velocity at rest, so that is 0, minus acceleration due to gravity and time taken. Okay, but then time taken is equivalent to this one, so we can substitute this value for the time taken. So therefore this becomes final velocity will be equal to negative g, then substitute the value of time taken, square root of 2h all over g. Now we will insert the g outside the radical sign inside. Okay, so this becomes negative square root of 2h then g squared. Okay, and then all over g. Then simplifying this one, eliminated. So that is the final answer will be negative square root of 2g and then h. So that will be our final velocity. But then, negative sign only indicates its direction. So the final formula will be this one. And you can write downward. Downward direction. Because if the ball is dropped from this position going down, okay, then the direction of the velocity is still going down. So that's why sometimes you get negative values for final velocity, and that negative sign indicates its direction. Okay, so additional formulas. Okay, so these are some common problems in free fall. So let's say a particle is projected vertically upward from the ground with initial velocity vi. So from the latter explanation of additional formulas, a ball is dropped from top of a building and its initial velocity is 0. No force is applied. But when we say a particle is projected vertically upward with initial velocity, there's a force applied to the object in order for the object to uh, go or projected upward. So let's say if this is the particle and it is projected vertically upward, okay, so going up, there is a force applied and that leads to an initial velocity. So initial velocity is not equal to 0. So there is a value. So most common questions for problems here, uh, find the maximum height h the particle will attain and the time t that it will take to return to the ground. So first is the maximum height it will reach. So when you throw a ball, let's say from point A going up, then reaching its maximum point at point B, this represents the maximum height. Okay, and when we say maximum height, that body or object will stop, okay, and it starts to go down again back to the ground. So there's a total time interval from going up and going down. So time 1 is going up and time 2 is going down. So time of ascent and time of descent. Okay, so based on this figure, okay, initial velocity is vi. So since the initial position, okay, and its final position is above the initial position, therefore value of s will be equal to positive height based on design and convention. Then vi is initial velocity and final velocity will be equal to 0. So that's the time when it reaches its highest point or maximum height. So initial final velocity is always equal to 0. Okay, and then total time taken, let's say consider point A to B. So motion A to B. So T1 or time of ascent, this is time. Okay, so simply going up first. Let us consider going up. Okay, so using the formula, final velocity minus I will be equal to initial velocity minus what's the formula? GD, acceleration due to gravity and time. So final velocity is 0, which will be equal to initial velocity minus g, acceleration due to gravity, time taken to going up, t1. Now solving for t1, we could say that time of ascent will be equal to initial velocity all over acceleration due to gravity. Now let us consider distance or displacement. S, initial velocity, time minus 1/2 g t squared. So S is positive h will be equal to initial velocity multiplied by time, which is t1, and then minus 1/2 acceleration due to gravity t1 squared. But then t1 has a value of vi all over g, so you can say that the maximum height will be equal to initial velocity multiplied by t1, which is initial velocity all over acceleration due to gravity minus 1/2 acceleration due to gravity, and t1 is initial velocity all over acceleration due to gravity, then square. Simplifying this given equation will be equal to initial velocity squared all over g, then minus 1/2. So this is square is distributed to the numerator and the denominator, so g you can simplify, so that becomes vi squared all over g. So same unknowns, so you can see that 1 minus 1/2 is simply 1/2. So 1 multiplied by vi, so that could lead to the initial velocity squared all over 2g. So you can solve for the maximum height. Okay, this one. So if this given problem is finding the maximum height, you can directly use this formula without doing everything I have done. So this is simply a shortcut. Okay, now let us solve for the time taken. Okay, time taken. Oops, I just remove the erase all the ink. Okay, now solving for the time taken. Now, as mentioned earlier, t1 is the time of ascent from A to B, which is equivalent to initial velocity all over acceleration due to gravity. And let us consider now motion from point B to A. So from point B going A, so this will be time of descent. So initial velocity here, well, let's say this will be final velocity 0 from the top, so this becomes initial velocity of descent till it reaches its final velocity. So this is also initial now when it goes down. Okay, now time of ascent can also be equal to time of descent, which is equivalent to total time taken. I mean first interval of time. So total time taken is time of ascent plus time of descent. So I could say that this is t1 plus t2, which is equivalent to vi all over g plus vi all over g, because we say ascent is equal to descent. So therefore that becomes 2 initial velocity all over g. This one. Or you can simply use the formula of displacement, initial velocity multiplied by time minus 1/2 gt squared. Okay, so S is displacement. So when the body or particle is thrown vertically upward and then reaches its maximum height and goes back to its initial position, so the displacement here is 0. Okay, we call displacement. Then initial velocity and time taken will be the total time elapsed, so that is from going up until returning back to the ground. Okay, so minus 1/2 acceleration due to gravity time squared. Okay, now simplifying, so this can become 1/2 gt squared will be equal to initial velocity multiplied by time. So dividing both sides by time, so eliminated. So simplifying, solving for t, so this becomes 2 initial velocity all over acceleration due to gravity. Okay, so basically problems in free fall, okay, when maximum height and the total time taken, you can use this formula. Okay, second common problem, okay, what will be the velocity when the particle returns to the ground? Okay, so second problem here. So similar problem, a particle is projected vertically upward from the ground with initial velocity vi. Okay, so what will be the velocity when the particle returns to the ground? So that is from initial, okay, then it reaches my highest peak or maximum height, then returns to the ground. So you have your final velocity will be unknown. That's the question. Now the answer would be this one. So final velocity will be the negative of the initial velocity when it was thrown vertically upward. So how are we going to prove this one? Okay, so using the previous formula from the previous example, initial final velocity is equivalent to negative square root of twice the acceleration of gravity and its maximum height. And recall, negative simply the direction of the final velocity that is going down, right? Okay, now final velocity will be equal to negative square root of 2 g, and maximum height, we call maximum height, that is initial velocity squared all over g. Now simplifying 2g, I mean, let's go back. There it is, 2g. Okay. Now simplifying, this will be eliminated, and therefore this will be final velocity will be equal to negative square root of initial velocity squared. So therefore final velocity is equivalent to negative of initial velocity. Okay, so when you encounter problems similar to this question, you can use directly this formula. Okay, and last will be, what will be the displacement and the distance traveled by the particle during this time of whole motion. Whole motion is from when it leaves the ground, highest point, and returns to the initial position. So we said that displacement is the shortest distance traveled regardless of the path. So that is equivalent to 0 because it returned to the initial position. Now, distance traveled. So distance. So the distance is the actual path of motion. So from initial going up, that is 1h, then going down, so twice the h. But then, so h is what? Initial velocity squared all over 2g. Then when you simplify this, you will have this one. Okay, so these are the common questions in problems involving vertical motion or free fall. Okay, so these are the common questions. So summary formula, as you all know, these are the original formulas. Okay, we replace acceleration with negative g, or negative acceleration due to gravity. So we come up to these three formulas. An additional formula, these two formulas are used for particle that is dropped with initial velocity equal to 0. Okay, then this refers to final velocity, and negative simply refers to the direction of your final velocity, which is going down. Okay, now these are the previous examples from the scenarios given. Maximum height, this is the time taken, what will be the final velocity when it reaches the ground. So its displacement is 0, and the distance of the whole motion is twice its maximum height. Okay,